Problem 15.5. So the question is that suppose we have a supplier that has a warehouse in the city A and city B, and it has two customers from the city C, city C and the city D. Okay, so city C required order 50 units of the product, and the city D required ordered 60 units of the product. And in warehouse A, it has 70 in stock, and the B has 80 in stock. So the cost of shipping those units are given by this following table. That means if you ship one unit from the city A, warehouse in city A, to the customer in city C, you will spend one unit of money. And from the city A to city D, you require 2. So that's the table right here. The question is, how do we formulate this problem to decide how many units we should ship from each of these two warehouses to each of these two customers? And the goal is to minimize the total cost of shipping. Okay, and we need to convert this into the standard form of the LP, the linear program. Okay, so now since the question is how many units we should ship from each of these two warehouses to each of those two customers, let's say that we form this table of variables to decide. The x1 indicates the number of units we should ship from A to C. And that's these 4 values are the unknowns. So the constraint is that the total number of units we shipped from A. So the total number received by the customer C must be equal to 50. That means the x1 plus x3 must be equal to 50. Okay, that's the number of units ordered by the customer in CTC. So that's why we have this first constraint. Similarly, the sum of these two must be equal to 60. And also because the warehouse A only has 70 in stock, so the sum of these two, the sum of the units shipped to these two customers from the warehouse A must be less than or equal to 70. Okay, that's this constraint. Similarly, the sum of these two must be less than or equal to 80. And all these units must be, number of units must be non-negative numbers. Okay, so that's why we have that. And the goal is to minimize the total cost. So remember that for every unit you ship from A to C, you incur a cost of $1, say. And then that's why the x1 is multiplied to 1. And similarly, this cost is $2 per unit, so the total cost would be 2 times x2. Okay, so that's the total cost. And this is the question. And as we can see, it's basically already in the form of a standard form, right? So because you have these linear inequalities, no, I should say that in this case, we still need to do something else to convert this to standard form. So for example, here you need to add a slack variable. For example, call it y1, so that y1 is positive, but the sum of x1, x2, and y1 is equal to 70. Similarly, you need to add one more slack variable in here. So eventually you have not only just x1 through x4, but also y1, y2. So this is our the standard form. Okay, I should add that right here. It should be equal to 70. And similarly, x2, so x3 plus x4 plus y2 must be equal to 80. And x1 through x4, the y1, y2, they must be greater than or equal to 0. The objective function doesn't change, and these two constraints doesn't change, do not change either. Okay, and then you convert this to a standard form of a linear program in the variables. There are 6 variables, x1 through x4, and y1, y2. Okay.